Hello friends, welcome you all. So in this lecture, we will discuss ambiguity in context-free grammar. So in here we will discuss what is ambiguous grammar and what is unambiguous grammar, how to convert ambiguous grammar into unambiguous grammar. So all these things we will discuss one by one. So first I will tell you what is ambiguous grammar. So in case if for generating any particular string from any given grammar, if you can use two different production and you can generate the same string, then you can consider this grammar as ambiguous grammar. Or in other way, if I tell you, if to generate any string from any given grammar, if you cannot at any point, if you cannot decide which production to use first, and if such situation is there, then you can also consider this grammar as ambiguous grammar. Now, I will take one example of ambiguous grammar and I will generate one string from this grammar in two different ways. So, here I am taking one example as E gives E plus E or E cross E or ID or ID. So this is one grammar, this is one grammar, and this is ambiguous grammar. This is ambiguous grammar. Now, how it is ambiguous? See, I can create one string ID plus ID cross ID. So I can create this string from this grammar. So how I would create? So I can use there. I will tell you. So I can start from E. I can start from E. Then I can use E plus E, production E plus E. And then I can replace this E with E cross E. Then I can replace this with ID. I can replace this E with ID and I can replace this E with ID. So here in this particular parse tree, you can see I started from E, then I used that production E plus E, and then second E I expanded as E cross E using this production, and then all E's were converted to ID using this last production. Now I can create one more parse tree for the same string from the same grammar. Now you can see E, we can start from E again. Now I can use this production first. So E cross E. Then this E I can replace with E plus E. And then all E's we can convert to ID. Now you can see, my friend, in both these parse tree, we are generating same string from same grammar. Now you can see when we started from E, we can take this production or we can take this production. Now there is confusion or there is ambiguity, like which production to use first. So in case at any point if you are having such situation, then such grammar is known as ambiguous grammar. And one more identification of ambiguous grammar is for any particular string, and you can create more than one parse tree from that particular grammar. So like this, here for this particular string, we have created two different parse tree from this grammar. That means this is ambiguous grammar. And in unambiguous grammar, you can only generate one parse tree for any particular string. You cannot generate any other parse tree for the same string from any grammar if the grammar is unambiguous. But with the ambiguous grammar, you can generate more than one parse tree for any particular string. And now again, you can have in any university exam or any competitive exam, you can have the question. Suppose one grammar is given to you, and one you need to prove that this particular grammar is ambiguous grammar. So how would you prove it? So you need to identify one string for which you can generate more than one parse tree for this from this grammar. And if you are successful in doing this, then you can prove this grammar as ambiguous grammar. So you need to identify the string carefully so that you can generate two different parse tree from this from the given grammar. And this is the way to prove any grammar as ambiguous grammar. So this particular grammar is ambiguous grammar because for this particular string we have created two different parse tree for this string. So now we have proved that this particular grammar is ambiguous grammar. Now the question is it possible to convert any ambiguous grammar in unambiguous grammar? Yes, it is possible. But now again one question is there, like all ambiguous grammar can be converted to unambiguous equivalent unambiguous grammar? No, all grammars cannot be converted to equivalent unambiguous grammar. And for the grammar which cannot be converted to unambiguous equivalent unambiguous grammar, they are considered as inherently ambiguous grammar. And this property of grammar is called as inherent ambiguity. Inherent ambiguity. So I hope this would be very much clear to all of you. Now I will take one example where we can convert any particular ambiguous grammar into unambiguous form. We have this particular grammar which is ambiguous. We have seen already. Now we will try to convert this particular grammar in equivalent unambiguous grammar. So this is not inherently ambiguous grammar because it can be converted into unambiguous form. So I will show you how to convert particular grammar into unambiguous form. Now you can identify unambiguous grammar like here you will have the same variable in the right hand side which is at the left hand side twice in the right hand side. So here you can see this is e plus e is at left hand side and e and two occurrences of e are there in the right hand side. Here also two occurrences of e are there in the right hand side. Now you can see if I want to convert this particular grammar into unambiguous form, then I will take one production rule at a time. So first I will consider E gives E plus E. Now out of these two occurrences of E here, we will replace any occurrence of E in with different variable. We will use one more variable. We will add one more variable in this grammar and we will replace one occurrence of E at right hand side with another variable, right? So I can use E gives E plus T. I have introduced one more variable T here. And I have replaced the right hand side occurrence of E with a T. Now as we are replacing E with a T, so there must be some production where we will generate T directly from E. So I have to add one more production here, E gives a T. I have to add one more production here, E gives a T. Now this particular production we have converted into unambiguous form. Now we consider this particular production. Now as we have already replaced this E with a T, So I can write this production as T gives T cross T. I can write this production as T gives T cross T. Now, again, this is having the same form. Left hand side variable is also having two occurrences in the right hand side. Now, again, we can replace one occurrence of right hand side variable with different variable. So, I can have now another variable as f. F. And if I replace this T with F, so there must be one production which is directly generating F from T. So I have added one more production there. T gives F. Now, as we have replaced this E with a T, then T with F, so I can write one more production here. F gives ID. F gives ID. F gives ID. So now, when we converted this production into an ambiguous form, so we got this. When we converted this production into an unambiguous form, so we got this, and this is unambiguous production already. So now we can remove these two production from here, and now this is the grammar which is unambiguous and equivalent to this grammar. Now, how two grammars are equivalent? That all strings that you can generate from this grammar, you can also generate from this grammar. All strings you can generate from this grammar, they can also be generated from this grammar. But the difference, this grammar is ambiguous grammar and this grammar is unambiguous grammar. Now, for this grammar, now for this string, from this grammar, you have generated two different parse tree. Now for the same string, with this grammar, you cannot generate more than one parse tree. Let's try. So we can start from generating this string from this grammar now. So we can have E first, then we can replace E with E plus T, then we can replace this T with T cross F, then we can replace this E with a T, then this T with F, then this F with ID, then this T with F, and this F with ID, then this F with ID. So now, this is the only parse tree that you can generate from this grammar for this particular string. You cannot generate more than one parse tree for this string from this grammar. So now this is unambiguous grammar and this is ambiguous grammar. Now we have converted this ambiguous grammar into unambiguous form. So these two will be equivalent. All strings that you can generate from this grammar, you can also generate from this grammar. So I hope this would be very much clear. Now I will tell you one more very important thing here. Now here I hope it would be very much clear. So I will remove all these things and then we will discuss one more important thing. So now friends, as you can see, while converting this ambiguous grammar into unambiguous form, you have noticed something. Each time I have replaced rightmost occurrence of left hand side variable with another variable. Like here, while I converted E gives E plus E in unambiguous form, so this occurrence of E I replaced with T. And similarly, when I replaced T, when we had one more production, T gives a T cross T, so I replaced this particular occurrence of T with another variable F. Now, how to decide which particular occurrence of left hand side variable in you should replace with another variable? So you can see if I can see why I have used right hand side occurrence to replace with another variable, see these plus and asterisk, the plus and asterisk. Now, if you have, suppose if you have 2 plus 2 plus 4, this expression you have, now which plus you will solve first, this plus or this plus? Although the result will be the same if you solve this or this. So 2 plus 2, 4 plus 4, 8. So result will be same in both the cases. But as we are doing this with computer, so we need to specify the proper sequence. Now, if two different operators are there, then it is very easy to identify the priority. But if the same variable are there, then how to decide the priority? So, in case of plus, we use we solve this left side plus first. That means this plus operator is left associative, right? Similarly, for multiplication operator, if you have 2 cross 2 cross 4, again the same variable in both the places. So again you solve this first while using computer, and after this whatever multiplication is there you will multiply 4 in the multiplication of these two. That means this is also left associative. So both the operators were left associative in this case. And if you are having left associative operator, so in that case, you will replace right occurrence of variable with another variable. Here, E plus E we are having, and plus is left associative operator. So we will replace rightmost occurrence of left hand side variable. So we will replace this particular occurrence of E with another variable. Similarly, when we had t gives t cross t, so again cross is or multiplication is left associative operator. So again we replace that particular rightmost side occurrence of variable with another variable. So in case of left associative operator, we replace right hand side occurrence of with a different another variable. If your operator is right associative, then we replace left occurrence of variable with another variable. For example, now what are right associative? What is the example of right associative operator? So now if I want to calculate 2 to the power 3 to the power 2 2, so this you can write in your computer system like this: 2 3, then again exponentiation 2. So now this would be here in this particular operation, this would be calculated first. And this will result in 2 to the power 9. This 3 to the power 2, so which will be 9. So this power will be given to 2. So this would be 512. Now, as you can see here, both the operators are same in this case also, like this. But here we are solving the rightmost operator first. In this particular example, we solved leftmost operator first, but in here we are solving rightmost operator first. So this is right associative operator. So this exponentiation is right associative operator. Right associative. Now, if you have such operator, between two occurrence of variable, then you will replace left side occurrence of with another variable. I will take this example. So now suppose this is your given grammar. This is your given grammar. Here we have one left associative operator and one right associative operator. So now how we would be converting this particular grammar into unambiguous form? So again we will use the same logic here, that if we are having two occurrences of same variable, left hand side variable here in right hand side, so I will replace one occurrence of this variable with another variable like t, and as we are replacing it with a t, so we must have a one production there where e will directly generate t. So I have used this. Now if I remove ambiguity from this production, so I got this production as t gives t cross t exponentiation t. Now, as we are having right associative operator here, so now this time we will replace left hand side occurrence of t with another variable. So I will write it as f exponentiation t, and f, as we are replacing one occurrence of t with f, so t must be f must be directly generated from t, so we need to add one more production, t gives f. Now as we have converted this e into t, then t into f, so we can write one more production here. In place of e gives id, I can directly write f gives id. So this is now, this production we can remove from here. Now this is the unambiguous version of this particular grammar. This is the unambiguous version of this particular grammar. So for left associative operator, we replace right occurrence of a variable with another variable. For right associative operator, we replace left occurrence of variable with another variable. So this is how we can convert an ambiguous grammar into unambiguous one. Now, I hope it would be very much clear to all of you. So, you can take some more example of right associative operator as conditional operator in C language. So, this is also right associative operator. So, I hope it would be very much clear to all of you. Now, if you have any query now, or you can always write to me in comments. I will definitely reply your comments. Thank you. Thank you so much.